Hello everyone! Have you ever wondered how to turn your machine learning predictions into a stunning web app? Well, today we're diving into exactly that. How to create an eye-catching, user-friendly UI using Flask to showcase Olympic medal predictions. In this video, I'll guide you through building a Flask app that takes 4 key inputs. Number of events. This is the total number of events a country participates in during the Olympics. Number of female athletes. Here, you'll input the count of female athletes representing the country. Number of male athletes. Similarly, this is where you enter the count of male athletes from the country. Previous medal count. This field is for the number of medals the country has won in previous Olympic Games. These inputs are entered through a user-friendly web interface that will build together, step by step. Prediction and output. Based on these inputs, the app will predict the number of medals the country is likely to win. The best part? The prediction is displayed directly on the same web page, providing instant feedback. By the end of this video, you won't just have a fully functional Flask app. You'll also have a clear understanding of how to use machine learning models to make predictions in a web environment. Setting up your project structure. Let's start by setting up the project structure. First, create a directory for your project and organize it as follows. Flask Olympic Predictor. This is the root directory of your Flask project. It contains all the necessary files and folders for the application. Templates. This folder stores all the HTML files used in your Flask application. By default, Flask looks for templates in this directory. Index.html. This is the main HTML file for your web application. It defines the structure and content of the web page, such as the input form and the area where the prediction result is displayed. Static. This folder holds static files like CSS, JavaScript, and images. These files are not dynamically generated and are served as is to the client. Style.css. This CSS file contains the styling rules that determine the visual appearance of your web page, such as the layout, colors, fonts, and spacing. Application.py. This is the main Python file that runs your Flask application. Olympic medal predictor.pkl. This file contains the pre-trained machine learning model and the associated scaler, serialized using the Pickle module. Creating the Flask application, app.py. Next, we'll move on to creating the Flask application. The first step is to import the necessary libraries. Flask. This is the core library that we're using to create the web application. Render template. This function is used to render HTML templates and return them to the user. Request. This is used to handle incoming data, like form inputs, in a web request. Pandas. A library for data manipulation, which we use to handle the input data. Pickle. This module is used to load the pre-trained machine learning model and scaler from a file. Loading the model and scaler. The pre-trained linear regression model and the scaler are stored in a Pickle file named Olympic medal predictor.pkl. This block of code will load them into memory so they can be used to make predictions. We'll use pickle.load to deserialize the data, allowing us to use the model and scaler within our Flask app. Initializing the Flask app. We then create an instance of the Flask class. The name variable in Python represents the name of the module. Flask uses this to determine the route path for locating resources. Defining the route and view function. We define the route and view function using the add-app route decorator. This sets the URL endpoint for the root of the web application, the methods get and post. part indicates that this route can handle both GET, for loading pages, and POST for handling form submissions, requests. Handling form submission. Here we capture the data submitted through the form on the web page. The form data is sent as a POST request, and each value is accessed using request.form, field name. We'll use int and float to convert the form data to the appropriate data types. Creating a data frame for the input data. The input data from the form is put into a Pandas data frame, as the scaler and model expect the input in a specific format. Scaling the input data. We'll use scaler.transform, input data, to scale the input data based on the scaling parameters learned during model training. This ensures the input data is in the same format as the data used to train the model. Making a prediction. The scaled input data is then passed to the pre-trained model to make a prediction. We'll use model.predict, input data scaled, to return a predicted value, and 0 is used to extract the value from the array. Rendering the template with the prediction. Finally, we use render template, index.html, predicted metal equals round prediction, to render the index.html template and pass the prediction result to it. The round prediction function rounds the predicted number of metals to the nearest whole number. Handling the default page load. If the page is loaded via a GET request, meaning when the user first visits the site or refreshes it, this line simply renders the index.html template without any prediction. Running the Flask app. The last step in this part is to run the Flask application. Setting debug equals true allows the app to reload automatically when you make changes to the code and provides detailed error messages during development. Creating the HTML template. Let's move on to creating the HTML template. We'll break down the HTML document structure, starting with the declaration, doctype HTML, which defines the document type and version of HTML being used. The HTML lang equals n tag specifies the language of the content, English in this case. Head section. In the head section, we have a few key elements. This code sets the character encoding to UTF-8, supporting most characters from all written languages. Ensures the web page is responsive, meaning it will adjust its layout depending on the device's screen size. Specifies the title of the web page, which appears in the Browser tab. Links to an external CSS file that contains the styles for the web page. The URL for function dynamically generates the URL for the CSS file, located in the static folder. Body section. Moving on to the body section, this is where the main content of the web page is placed. It contains a container element that holds all the content. Olympic medal predictor is the main heading of the web page. Form section. Next, we create the form. This code creates a form that allows users to input data. The method equals post specifies that the form data will be sent to the server using a post request when the form is submitted. Label and input pairs are used to collect user data. For example, number of events is a label for the input field where the user will enter the number of events. Similar pairs are used for entering the number of female athletes, male athletes, and previous medals. Step equals any allows the input field for previous medals to accept any decimal value. Predict medals is the button that submits the form. When clicked, the form data is sent to the server for processing. conditional display of results. Lastly, we have a section for displaying the prediction. If predicted metal is not none, is a Jinja2 template conditional statement that checks if a prediction has been made. div class equals result contains the result of the prediction. Predicted metals displays the predicted number of metals. Closing tags. Finally, we close all the tags to complete the HTML structure. Add CSS for styling. Global styles. The styles inside this block apply to the entire web page. Container styles. Styles for the container class which wraps the main content of the page. Heading styles. Styles for the main heading. Form styles. Styles for the form element. Label styles. Styles for the label elements. Input field styles. Styles for input fields where the type is number. Button styles. Styles for the button element. Button hover effect. Styles applied to the button when a user hovers over it. Result box styles. Styles for the result box that displays the predicted number of metals. Running the Flask application. Now let's run the Flask application by executing the script in your terminal. Once running, open a web browser and go to http://127.0.0.1:5000/. Here you'll see the UI where you can enter the number of events, female and male athletes, and previous medals to predict the number of medals the country might win. I trust you found this video helpful. Don't forget to check out the description below for the dataset and code. Thank you for watching.